Emma. 81.2. Can I add something to that to be a little more descriptive? I'll give you a hint, it's not feet.
Oh, degrees.
Degrees, thank you. Thank you, awesome. Is that what everyone got? I don't have it. Okay. I just assume if no one's yelling at me, it's probably the right answer. All right. Can someone tell me how to set up angle L and also give me the answer? So you have to do two things. David.
Angle L equals inverse tangent 13/84.
13 over 84. Coo, coo, coo. And what does that equal? About
8.8.
8.8. How do I know right now I did everything correct? They add up to 90. They might add up to 89.9 because you're just rounding. But as long as it's not like 86 degrees, you know you pretty much did it right. Okay. So like I said, if you did not know how to do that, make sure you go home and you practice this. Real quick, and I know we're going to kind of run out of time with stuff. I'm going to try to do it as fast as possible. Questions on the homework, because I know there are questions on the homework. Hannah. Number 20. So as surprising as it seems, number 20 and number 19 are almost the exact same question. They don't look it, but they are. They're almost the exact. So how about I look at how we solve 19, and then I'll look at how we solve 20. That might be a good way to look at those two things. So on number 19, that was the same thing we did in class, right? Number 19, right? Yeah. Was the same thing we did in class. We just had to draw a right triangle. That's not going to look good. Let's go ahead and give me some space to write. So this is number 19, and correct me if this isn't what you did, but you would draw basically our road. And we draw a triangle. And since it's 7%, we'd write a 7 over 100. And we solved for that angle, right? Does that match what people did on number 19? Where basically I did tan inverse of 7 over 100 gave me this angle. Well, let's look at 20. 20 tells me that it is an 8-degree angle, and it wants me to tell you what grade it is. So I'm like an engineer. I'm an engineer, and I need to make one of those signs. And we measure everything, and we find out that this measure right here, so we'll keep the same shape, right, because we're going uphill. But all I know is I use one of those like thingamajigs, I forget what they're called. But we measure it, and it comes out to 8 degrees. But for our sign, what was that? Thingamajigs. It's not a protractor. I forget the technical name. They'll have it on, like they have it on like a tripod, and you'll see them when they do road work. It's got a very specific name. I want to figure out what degree it is. Well, I know the degree. I want to figure out what percent grade it is so I can put it on that sign. All right. Well, we know percent is per 100. It goes how high up per 100 feet. So I know that if I'm ever dealing with grades of road, we're always going to make a triangle with 100 on the base. So if I'm talking about roads, we automatically put 100 here. Now either I know this number or I know this number. In number 20 and 19, I knew that number. In this one, I know that number, and I need to find this number. Okay, so I would do tangent of 8 equals x over 100, solve for x, and that will be my percent grade. Okay, does that make sense though? Does that make sense? I'm sure other people have that same question. Does that make sense to everyone? Please ask if you're just like, what road? What's a percent? I don't even care if that's a question. I just want to make sure everything's clarified. Okay, other questions from the homework? Like I said, I'm probably not going to go through all of them, but yeah. 24. So people that ask first get priority. Is 24 up there? 24 is up there, awesome. I don't take another picture. 24 is a great question. Why is it a great question? Because if I put it on the homework, on the test, I love questions that have word problems because I know if I just draw a picture, Mr. Pabian's going to give me points. So number 24 says I need to draw a rectangle that's 80 centimeters wide and 20, or doesn't really matter, but 80 by 20. I'm actually going to label everything 80, 20. And then it talks about the diagonals. It says find to the nearest degree the acute angle formed by the intersection of the diagonals. I'm going to stop at drawing one diagonal. And why I'm going to stop there is because it's a right triangle. This is a right triangle where I know two of the sides. This is a right triangle where if I want to find this measure right here, let's call it A. Let's call this A. Let's call this A. How do I find the measure of A? Mazin?
You can do tan inverse.
Yep. So measure of A is going to equal tangent inverse, and tangent is TOA, so that's opposite, over adjacent. And who got that measure? Who actually did that work and got that measure? What does that one equal?
Oh, I did it wrong. Well, it might actually be might be the right answer because
Did you do this one?
I did a different one. I got 76 and 14 degrees.
76 is
Yep, 76 is this one. Yep, this one's 76 degrees. Was it 76 point something or was it 70? Let's just say it comes out to 76%, okay? Or degrees. So that means that this measure right here is 76 degrees. So we're going to say this is about, I know I'm kind of running out of room, you kind of have to follow along, but that's about 76. And that's in fact all I needed to find on this one. Because if I drew my other diagonal, if this equals 76 degrees, that means this one has to equal 76 degrees because this is an isosceles triangle. Because in a rectangle, our lines bisect each other. So this one would be 76 degrees. And if that's 76, that's 76. What is the measure of that one right there? Who's got their calculator and can easily do 180 minus 76 minus 76?
28.
What was that?
28.
So that's about 28 degrees. It was quick, messy, but do we have any questions on what I just did? All right, so any one of these drawings you're looking out for right triangles. Yeah.
I did it differently and I got the same answer.
What'd you do?
So I did tan inverse of 20 over 80.
So you got this angle. Yep.
And then I didn't get 28 though, I got 14 for the other measurements. Because aren't they all right angles in the rectangle? They all have that up to 90.
Yeah, you should have got 14 down here.
Okay.
You should have got 14 here. This one should have been 14, if I remember correctly from the book. This one should have been 14. Just double check. And if it's wrong, just come see me and we'll figure it out, okay? All right, other questions from the homework? Yeah. Number 30.
Oh, never mind, I have that.
Oh, okay. Okay, number 30. Number 30, we're using that diagram. I'm probably not going to go all the way through it because the book goes all the way through it, so we're just going to talk about it. So we're using the figure to find E to F, right? I'm trying to find E to F. Okay, well let's look at this big triangle. Let's get, because we know that I really want this triangle. I want to know what's happening with this triangle. But in order to do anything, I need to use this bigger triangle. I need to figure out what this side is. I'm going to call that X. I'm going to call that X. And if I look at that 32 degrees, I can write tangent of 32 degrees equals, well that's opposite, which is X, over 355. Can I use that to get to X? Does that make sense? How we can get to x that way? Did anyone solve for x or get that side? It's okay if we didn't. Yeah, what'd you get?
I got 209.3.
So 209.3 or about somewhere out there.
Wait, GF. I got 222 for GF.
Ooh. So I want to calculate 355 times tangent of 32.
It's 222.
It's 222.
222 too.
Okay, 222. Probably just a calculator.
I'm sorry, Haley.
Because it's the worst thing in the world to be wrong. You have to just, because no one's been wrong in the history of the world. Okay, it's 222. But wait a minute. Now I have everything I need. I actually only needed to do 2 steps, because now I can do the tangent of 44 is going to equal 222 over this missing length. Okay, is that good enough, far enough? All right, other questions? Yeah,
Are we going to derive sine, cos, and tan?
we don't actually derive them. We're just given them. They're words that we came up. We use sine, tangent, and the other ones to come up with other stuff. It's sort of like our basics. But yeah, we're going to talk about the other 3 today, and that leads us into the other 2 trig functions. So, like I said, we don't really derive them because we came up with the name for them. We just saw a ratio and we named them. Okay, so far we've only talked about tangent. And that's because sine and cosine follow all the same rules except we use different sides. Alright, so on how we find angles and how we find sides all stay the same except we're using different parts of the triangle. So when we talked about tangent, we always said TOA because it was opposite over adjacent. We did it over and over. Opposite over adjacent, opposite over adjacent, opposite over adjacent. That's why I said TOA. Well, let's start with one new one. One new one is called sine. All right, we use S-I-N, but it's actually spelled S-I-N-E, but we just say sine. Whenever you see that, you say sine. So S-I-N-A. Well, sine, when we had tangent, tangent was opposite over adjacent. Sine, on the other hand, is going to be opposite over hypotenuse. So this time we use hypotenuse on this one. So tangent we used adjacent, here we use a hypotenuse. We'd call it SO. To remember it, we say SO. SO stands for opposite over hypotenuse. The other new one we're going to do is cosine. For cosine, we just write COS because it doesn't pay to write the whole word cosine over and over and over to get horrible. So we just write down cos, or cos. But we're going to say cosine every time we see this. So whenever you see COS, you're just going to say cosine. Well, the cosine of an angle is going to be adjacent over hypotenuse. So to remember that, we're going to say ka. And why we come up with these is because we come up with this very famous saying called SOHCAHTOA. Whenever someone says trig, your immediate reaction should be SOHCAHTOA. Alright, SOHCAHTOA breaks down to SO, which is sine, is opposite over hypotenuse. Ka, cosine is adjacent over hypotenuse. TOA, which is tangent, which is our opposite over adjacent. So SOHCAHTOA. And we're all going to say it together because we need to know it. So on 3. 1, 2, 3. SOHCAHTOA. And again, SOHCAHTOA. And in a high-pitched voice, SOHCAHTOA. In a low-pitched voice, SOHCAHTOA.
Oh, I really like this class.
And a singing voice.
No.
I know.
No.
So SOHCAHTOA, say it over and over until you remember it. You don't know this on the test, you don't do well on the test. It's just that simple. And it's this one little saying can be the difference between you passing the test and you failing a test. Alright, one little saying, that's SOHCAHTOA. So if you have to say it over and over and over and over tonight, do it. You're going to use it now, in Algebra 2, in pre-calculus, in calculus, and pretty much every math class after. SOHCAHTOA is that important. All right. So using this. All right, if I ask for the sine of A, my sine of A, we're going to remember SO. SO is opposite over hypotenuse. So sine of A is going to be opposite, which is A, over hypotenuse. Our hypotenuse is C. The good thing is on a triangle, our hypotenuse we can always find. So we can always label our hypotenuse. Our adjacent and opposite change depending on what angle we're talking about. So as soon as I see a triangle, I always locate my hypotenuse. We've done that in every single section so far. We locate our hypotenuse right off the bat. So that's my hypotenuse. All right, let's go to cosine. Cosine is our ka. SOHCAHTOA. So that's adjacent over hypotenuse. If I find angle A, my adjacent is B. And it's going to be B over my hypotenuse, which is C. Finally, good old-fashioned tangent. It's our TOA. It's our opposite over adjacent. Well, opposite of A is A. And my adjacent is B. I want you to go ahead and do the ones underneath it. Go ahead and do those three underneath it. So you're going to find your sine of B, cosine of B, and tangent of B. C over C. Oh, okay. But that's not correct. Let's look at B. Point to angle B.
Oh, and I did side B.
Oh, okay. It's always angle.
Okay.
All right. So that would be opposite over hypotenuse. There you go. Yeah. Yeah. I think. I just lose the first one. Maurice, what is sine of B?
B over C.
B over C, because it's opposite over hypotenuse C. Wendy, what's cosine of B? A over C. And Haley, what's tangent of B?
B over A.
B over A.
A over A.
None of them are A over A.
Is that? Oh, you said B. Okay.
Okay, yeah. Maybe I said A over A. Maybe I did. Who knows? Who knows what I say most of the time? Okay, so that's how we do it. It's still the same stuff. As long as you remember SOHCAHTOA, it all works the same as what we did with tangent. So if I'm supposed to express each of these as a ratio, and I want to find sine of A. Can someone tell me what sine of A equals? Mazin. It's going to be 5 over 13 because this is my hypotenuse. I would have that labeled to begin with. All right, can someone tell me what cosine of A equals? Brian.
12 over 13.
It's going to be 12 over 13 because it's adjacent over hypotenuse. The good thing about sine and cosine, we should always have the bottom right. If I ever have to do sine or cosine, I should automatically, hypotenuse is the easiest one to find because I don't even have to look at the angle. I know it's hypotenuse. So as soon as I say sine or cosine, you should have the bottoms right or denominators right. The different one is tangent because tangent, the bottom is going to dictate what angle I'm talking about. What is the tangent of, make sure you're careful because it's of B, not of A. What's the tangent of B? The tangent of B is going to be opposite, which is 12, and adjacent, which is 5. Nailed it. All right, so that's sine and cosine. Let's use it a little bit more. Let's use it in some actual examples. We're going to use it to find x. we don't have just tangent anymore, right? Tangent was easy because I always knew it was going to be opposite over adjacent. However, now we have sine and cosine, so we're throwing hypotenuse in the mix. So whenever I have a triangle and I'm trying to use sine, tangent, or any one of my trig functions, I'm either going to mentally or I'm actually going to physically label the triangle. So the first thing I'm going to note is my hypotenuse. I know that's my hypotenuse. I'll go to my next triangle. That's my hypotenuse. I'll go to my next triangle. That's my hypotenuse. That can't change. My hypotenuse is my hypotenuse no matter which angle I'm looking at. All right, now let's go back to that first one. I'm guessing I'm using this degree, right? I'm using this degree here. So I'm going to go straight across. This must be my opposite. That must be my opposite. Which makes the 18 my adjacent. Now because we have 3 to choose from, I'm going to ask myself, which one uses just the opposite and the adjacent? Which one of those 3 trigs uses opposite and uses adjacent, Hannah? The tangent. So we're going to use tangent, which is TOA, opposite over adjacent. So we're going to say the tangent of 25 degrees is going to equal opposite, which is x, over adjacent, which is 18. Well, that's nice that I have it labeled like that. All right, I need to get rid of that 18, so I need to multiply by 18, so they turn to 1. Pretty sure I'm not allowed to do one side. I have to do it to both sides, so I would also multiply the other side by the 18. I kind of ran out of room, so I'll write it down here. 18 times tangent of 25 degrees equals x. So x is going to be about, careful, read the directions before you give me the answer. Jack, do you need a calculator?
Oh, yeah.
Make sure you grab one, otherwise you're just sitting there. Math is not a spectator sport. Hannah. 8.39. Is that degrees?
Wait,
No.
if you have 8 point, well, I'm blank.
It is 8.39. That was like, you just gave him like the death stare too. You're like, don't correct me.
Wait, what?
Yeah, because she read it's supposed to be the 100th. Do you think it's important to read directions and round to the correct thing? Yeah, 8.4 will probably lose half a point. 8.39 gets you your full point. All right, our next one, I already have my hypotenuse labeled. I'm going to look at, well, this one is the one I'm using. So I'm going to go across. That's my opposite. This is my adjacent, but I really didn't even need to mark down my adjacent. So which one deals with opposite and hypotenuse? Opposite and hypotenuse, yeah. Sine. Sine, yep. Because sine is our so. So that means I can write down the sine of the angle I'm looking at, which is 38 degrees, is going to equal opposite over hypotenuse, which is 20 square root of 2. Ugly number. Good thing we have a calculator on hand, because I just need to multiply both sides by 20 square root of 2. And I'm going to have 20 square root of 2 times sine of 38 degrees. I'm running out of room a little bit. What is that about? About. MJ, you got us at the beginning. What do we got?
169.
Ooh. That seems a bit big. What do you get, Sean? You
17.41.
17.41. Just double check on how you're plugging it in. Our last one. Well, I'm looking for x because it's labeled. The one opposite of it is called our opposite, and we have adjacent. That means the only ones that are labeled are adjacent and our hypotenuse. Which one uses adjacent and uses hypotenuse? Cosine or cos. It's our cosine. So we're going to say cosine. I'm going to leave a little bit more room. I'm going to say cosine of x equals, cosine is ca, so it's adjacent over hypotenuse, 11 over 16. Maybe I should write that. Ka. SOHCAHTOA. Crap. Does that say x equals? Can I plug cosine x in my calculator? Does anyone calculator have an x button on it that you can just type in cosine x? Some might have an x button, but it's not going to solve it for you. How do I get x by itself? It works the exact same way with what we did with tangent. Haley?
Multiply both sides by inverse.
You're not actually multiplying, you're actually taking. It's called taking the inverse. Because it's cosine of x, we're going to do cosine inverse of this side, which means I'm going to do cosine inverse of this side. Well, our cosine inverse and cosine, they're specifically designed to cancel each other out and turn to 1. So that's going to leave us once again with, if I'm looking for an angle, I'm just going to put the angle I'm looking for. I'm going to put the inverse of the trig function I want to use. And I just have to put, well, if I'm doing cosine inverse, I need to have adjacent over hypotenuse. And guess what? All of your calculators, your calculator, your calculator, your calculator, has a cosine inverse button, just like a sine inverse button. So let's go ahead and plug that in, and someone tell me what this equals. About. Grace?
46.57.
46.57? 57 feet? Degrees. Cool. No one yelled at me, so I'm guessing that's the right answer. That leads us to our inverses. Too much. It's all the exact same thing as tangent.
The good thing is that this is all trigonometry.
Yes, this is what almost all trigonometry is based upon. Okay, so sine is, this is like your major cheat sheet. Sine is opposite over hypotenuse, SOHCAHTOA, which means if I need to find an angle using sine, I'm going to say sine inverse is opposite, sine inverse opposite hypotenuse. Cosine is adjacent over hypotenuse, so if I'm looking for the angle, I just do cosine inverse of adjacent over hypotenuse. And finally, if I have tangent and I'm looking for an angle, I'm going to use tan inverse of opposite over adjacent. I don't know why. Okay,